Oceans and asteroids? NASA turning asteroids into comets? Give me a break. We often have thought of asteroids as islands in the vast ocean of space. But now consider that some people are talking about oceans within asteroids. Yeah, they're using that word. Might be a bit of a stretch, but they're using that word even with some of the smaller asteroids. I'm not talking about Ceres and Vesta. I'm talking about, they're still good sized asteroids, but the more run-of-the-mill rubble pile asteroids having had water within them. Now, some of us have talked and know about these things called water-bearing asteroids, but we're going to take this to a new level because, there's that old adage, where there's water, there's life. Now, hey, I don't know about that, but it is an interesting suggestion. It's an interesting topic to toy with, especially with the considerations of the idea of panspermia. And you might have noticed I've got a video, one of the earliest videos on this channel is with Richard Hoover talking about panspermia and what seems to be fossils of diatoms and even algae and meteorites. Meteorites that he found in Antarctica and has been studied for years. So yeah, he's not popular in some of the scientific circles, but he is within certain circles. But anyway, let's say it's a very interesting topic to entertain. So let's get all into this asteroid oceans or whales, maybe, bodies of water. Well, so we're going to do a screen share. We're going to look at some of the latest literature and articles thereupon. And my friends, it is very interesting indeed. Study analysis of asteroid reveals unexpected evidence of mini ocean and carbonation. Hey, carbonated water, how much better can you get than that? Mini ocean. Okay, I think that might be a little bit of a stretch, but it's an interesting proposition to consider. And this was published in Inverse. I'm not going to go all through this article. I will show you instead here from Wikipedia, which doesn't mind us showing the content so much because anybody can come here and look at Wikipedia. So my friends, from Wikipedia, they're talking about these organic molecules and liquid water and aqueous alteration here. And they're talking about this with asteroid Ryugu. This is the one that was visited by the Japanese probe Hayabusa 2, which had samples returned to Earth. And these samples included a crystal with carbonated water in it. Hey, the kind you put in your fizzy drinks, right? Yes. So as interesting as it sounds, it was actually found in a hexagonal iron sulfide crystal. As this article here talks about carbonated water discovered in one crystal. I'm talking about carbonated liquid water. Let me rephrase that. They actually found carbonated liquid water in a sample returned by Hayabusa 2 from this asteroid. And my friends, so like I said, it was found inside this hexagonal iron sulfide crystal. But what they found was these crystals were shaped like coral reefs. There were a bunch of them. And they say these crystals were formed or likely formed in liquid water. So the crystals themselves formed inside of water. At one time, this asteroid had apparently a good bit of water, is what they believe. But what they think happened was this asteroid got hit by another body, a smaller asteroid, the original parent body here. So it was kind of churned. The insides were turned to the outside. The outsides are turned to the inside. My stomach feels like that sometimes when I take bad water. So the interior surfaces and material were mixed. And say today, Ryugu has both interior and parent body surface material on the surface. And since some of the material from the interior is on the surface, when Hayabusa come there to collect materials off the surface, it got a sample of what the interior of that asteroid used to be like, sans the being boiled off by the sun for the fact it's in inside an orbit closer to the sun. See, in the world of asteroids and planetary bodies, there's something they refer to as the frost line within our solar system, and you get the same in other solar systems. Beyond a certain radius away from the parent star, things get cooler and cooler. And once you get to a certain point, things freeze. You're outside the Goldilocks zone. It's known as the frost line. and this frost line is outside the main belt asteroid. So you might say Mars is somewhat in the Goldilocks zone too. It's kind of a bit cold though where Mars is at, and more so the main belt asteroids. And Ceres probably has a good bit of liquid water in it, maybe even Vesta. The two asteroids are so large that gravity has crushed the materials down within them into a sphere. And that's what happens once you reach a certain size as a planetary body. The smaller bodies do not get crushed in the spheres. They just don't have sufficient gravity for that. And the ones that spin kind of bulge at the stomach, kind of like Earth or some of us. Some of us manage that without spinning, right? All right. So, hey, guys, I like to have a little humor. So we like to mix the science and the humor here. And I do that on all my channels. It's worth a laugh. It's good for the soul. But anyway, guys, so we look at this here. And what they said is that this body had these hydrosilicates, its organic molecules. So they believe that this parent body for asteroid 162173 Ryugu was actually originally formed in the outer solar system, somewhere just beyond the frost line, and it migrated inwards and apparently stayed liquid on the inside. There's a lot of the ideas that some of these so-called water-bearing asteroids, we'll cover that in a minute, are actually extinct comets that settled down in the inner solar system. And it's thought that over time, some of these comets and water-bearing asteroids and some of the asteroids, it wasn't comets really to start with, they were just formed outside of frost line. And of course, comets, they can come from way out the cross line, outside the cross line, the Kuiper belt. So they think that, or it's thought by many, that once they spend some time in the solar system, the more volatile materials that the sun would cook off will evaporate from the surface more and more over time. But and some of these, especially organic carbonaceous chondritic asteroids, would form like a tar surface, they think, that might kind of seal things a bit. Although from what we've seen so far, everything looks like a rubble pile. Maybe the tar is like flex seal sprayed between the joints of the rocks. You got to have a little fun. I like to talk about flex seal, especially when I'm talking about Artemis with the leaks, right? I say, get out there with some flex seal. But anyway, so it's thought that might help contain what's inside, plus it would get it heated up inside as the asteroid gets near the sun, which would give you more liquid water, especially if it's a comet, like a derelict comet or any comet. They get close to the sun to heat up. Some people who believe in panspermia believe that's an opportunity for life forms that were in suspended animation or frozen out at distance when it comes to the sun to reanimate and have a period of metabolic activity, eating and doing whatever they do within the contents of said asteroidal or cometary body, reproducing, and then going back into suspended animation, being frozen as they go, kind of like sea monkeys when the water dries out. Ever had sea monkeys as a kid? They're little brine shrimp they call sea monkeys, which you dry them out, you can totally dry it out, and the little sea monkeys will go into little crystals, and you can keep them on a shelf or wherever it's crystals for a long time. Then you put the water to them, poof, out they come again. Kind of magic, right? Well, that's the kind of the idea of what's happening with that, if you should believe in panspermia. I'm not saying you shouldn't, or should or shouldn't, but the interesting thing is just about as soon as the rocks on Earth cooled down enough for there to be life, there was all these little single cell organisms almost immediately. And I've talked in the previous videos about how complex just the proteins, not the DNA, just the proteins are, and then probability of them forming just right. So it's interesting that Earth would have life so soon. So that may mean that we got a lot of cousins out there. If you're from the South, you know what I mean, cuz. All right, like I said, we got to have some humor here. Asteroidal water. This is the idea that a lot of asteroids actually have water deposits within them. And we're talking small solar system bodies, not the big asteroids. That's an odd looking graph to go with that topic. Anyway, so not small solar system bodies, not explicitly in the subcategory of comets. So maybe they never were comets. Some of them might be burned out comets, that are now in the inner solar system. Here's talking about the snow line, that area beyond which things are thought to freeze. outside the main belt of asteroids. So, and if you go outside, if you look at the moons of Jupiter, and there's a Trojan asteroids that are in the L4 and L5 orbits of Jupiter that may be very rich in water. So this is what's interesting about them. And the thing that I take to heart here is that the whole discussion that, hey, if we're moving out into space, see, the inner solar system, the sun is baked. Like, look at the inner planets, the inner bodies that are close in the solar system within this frost line. The sun bakes the volatile materials out of. Like, look at the moon. There's nothing there on the surface of the moon except maybe the permanently shattered craters. Mercury's actually thought to have ice on it, closest planet to the sun, but in permanently shattered craters in its polar regions too. We've actually found evidence of ice with radar reflections. I think some of the probes that went by have since seen the ice. Venus, no ice. That atmosphere on Venus that just covers the whole planet is just way too hot. But at one time, Venus may have had water. That's thought to be the case. Maybe life. Maybe there were dinosaurs on Venus, and then Venus went poof. It's runaway greenhouse effect. So the cool thing about water is it's very useful for deep space exploration, space settlement, because we can use it to make rocket fuel, water to consume, and for agricultural purposes. This is what, if it provided they don't have some little sea monkeys already swimming in it. Tardigrades more likely, or something, or maybe just diatoms. Diatoms seem to be very survivable, much more so than a lot of other things. Algae, that's what algae is made out of, or diatomaceous earth, for those of you that are organic gardeners, such as myself. All right, so guys, let's move on here and look at this, guys. So if you had diatomaceous earth, if you had water-bearing asteroids, if you're tapping into them, then you've got already available in space material resources. Now, some of this apparently is within the inner solar system. That's what we're talking about back here, that these come in the inner solar system, and this water may be available. Some of these asteroids that came in from outside, Venus comet, Versus. So some of these bodies have water on them, and some of them are in, or some of them are near Earth asteroids. Now, these chondrites, this is different forms of meteorites, my friends, different classes and forms of meteorites. Typically, the older classes were just stony meteorites, iron, metallic meteorites, and carbonaceous chondritic asteroids. And the ones with water would tend to be the carbonaceous sort. All right, so let's go back over here. The cool thing is, once you got the water, you might do stuff like this. Talking about islands in space earlier. Well, we may make our own islands in space instead of colonizing planets. This idea is known as the O'Neill cylinders here. This concept was hatched out by Gerard K. O'Neill back in the, started out when we started going to the moon in 1969. He asked one of his physics, they had to teach freshman physics. He was a research professor, researching magnetic storage rings, high-speed particle colliders, and those kind of things. And so, the researchers usually didn't like teaching the lower level classes, especially the Physics 101 class. So he thought he'd pose an interesting question to his students. He said, we were going to the moon that year. And so he said, hey, is a planetary civilization the correct place? Is a planet the best place for a civilization? And to his surprise, they came back with the answer, no. That was actually to his surprise. And they went into, I won't go all into it here, we'll do a story on this in the future, but these ideas for cylinders built with 1970s bridge building technology that would be 20 miles long, 4 miles in diameter, and rotate. You need two of them to balance each other's centrifugal force. So you keep them pointed at the sun. These big mirrors put light through windows, and on the alternate side away from that window was a land area. So you could have permanent light, and you could have tailored agricultural modules out here, which could increase the CO2 in to make plants grow better. Plants like CO2, and they like lots of it. They're optimized for 1,200 parts per million, because the Earth used to be a lot higher than that. Contrary to what some people would scare you with, right? So, but yeah, back in the days of the dinosaurs. And let's go back into this. Some of these are real pretty. So let me show you some more of these. I'll just click over. This is the notion of an interior view of an O'Neill cylinder. There's the mirrors. The mirrors point at the sun. You see the sun out here is probably the Earth and the moon, but inside is land. trees, rivers, lakes, homes, clouds, and rain because of the size of it. You know, it actually rains in the Vehicle Assembly Building at Kennedy Space Center because it's so big. So that's not a stretch. You could absolutely get rain, and you could probably artificially control the humidity and temperature with light and other adjustments. So it would rain when you wanted it to, like maybe at 9 o'clock in the morning, right after you went to work and you're sitting in your office, or 5 o'clock in the afternoon after you get through working in your gardens and fields if you live on this spot, huh? So interesting concepts there, my friends. And yeah, some other photographs. And there's other ideas. This is the idea of a Golden Gate Bridge inside of one. And here you can see the agricultural modules. You can see the other facility, a land area in it, you know, blah, blah, blah. So a lot of cool ideas here. This is supposed to be a river, a cabin, some kids out by the creek, somebody walking in it. And here was the idea of how we would, he thought we'd get the materials to build them mostly from the moon. He thought we'd have to bring some of that stuff up from Earth, but now we know what we know about these water-bearing asteroids. Not so much. You know, it only costs us 20th as much to get materials off the moon surface as it does the surface of the Earth in terms of energy. It costs a lot more to get stuff off the Earth, though, because most of the energy goes to lift and fuel, because it takes so much fuel. Here, you don't have to do that at all. And so a linear electric motor called a coil gun or a mass driver could do so relatively cheap from the lunar surface. This is going to be the subject of my why we don't want China to beat us the moon video in the near future. Another view with an eclipse of inside. So they got a little darkness and looks like kind of autumnish. Other ideas for these colonies. And there's pictures for stuff called Stanford Tourist, smaller versions called Stanford Tourist, vernal spheres, and many other concepts since then. I'm not going to share all that right now. So we're going to go over here. This is the guy who came up with this concept, Gerard K. O'Neill. And this picture is him from 1977, about 3 years before I met him, actually. So he got a very Spockish looking haircut there. Gerard K. O'Neill was a brilliant man, a really good man. He dedicated his life to this concept once they figured out what could be done. It was very revolutionary. So, you know, it was part of the doomsday has been canceled kind of notion, because all the people out there talking neo-Malthusism, saying limits to growth was going to end us. So I'm going to come back to that in a minute, guys. I'm going to come back to O'Neill in just a few minutes, guys. So hang on for that. I'll show you my little personal connection to Gerard K. O'Neill. All right, my friends. So kind of what may be a testament to this, the DART mission, which struck asteroid Dimorphos just a few days ago, has left a 6,000-mile cometary tail. Yes, it has a tail now, like a comet, 6,000 miles long. Now, we believe that comets are dirty snowballs. And we believe it's we believe this is Dimorphos. We believe that that's why you get these, when it goes around the sun, the stuff evaporates from the comet, the water boils and the other volatiles stream out and form the tail. Well, now we got that with an asteroid we just smacked into. So guys, this is really exciting. This was discovered in Chile by their SOAR telescope by the NOR lab in Chile. That's how they found this thing, guys. I shouldn't be scrolling through this, my bad. But I just wanted you to see this. This comet that NASA hit has got a tail that's 10,000 kilometers or 6,000 miles long. So is that a testament that maybe this little body right here also had water in it? Or is it just dust? Everybody asked about this. If you look at that real close, you can see it looks like it's irregular. This is just probably a rocket sticking up. The sun is shining mostly here, but it's over here. You can see some shadows. That little rock is shining good. So this is kind of like that, maybe. Everybody asked about that. Is it a door? Did somebody open the door? Is it hollow inside? Well, if it was, the guys inside are not very happy now. I kind of think not, because this is a big rubble pile. But my friends, this big rubble pile has some stuff down inside. And this isn't the biggest asteroid, guys. You know, this thing orbits asteroid Didymos. This is a asteroidal moon, the moon to a little bit bigger asteroid, and Didymos is far from being the biggest asteroid around. So bang, this is the orbit of Dimorphos and Didymos, dual asteroid. That's the dual asteroid redirection, test, DART was all about. And, DART had to travel millions of miles to get to it. You see, this thing comes from about the area of the main belt of asteroids now. It's outside the orbit of Mars. And just for purposes, look at the blue line is Earth's orbit. Mars orbit's way out here. Look how close Earth and Venus are. And Mercury's a good ways from the sun, a lot further than a lot of people think. But Venus and Earth are very close in orbits. Probably the two closest planets in our solar system are the Venus and Earth. But Venus has no moon. It spins in the opposite direction from Earth, and it takes it almost a Venetian year to spin. Not quite, but almost a Venetian year to spin around and create a day at the surface. But the winds and the clouds above circle the planet almost on a 24-hour basis at some latitudes. And even though the surface is twice as hot as a soldering iron, at about 50 kilometers, 30 miles up, it's like Earth. The temperatures and pressures are just like Earth. You just got to wear a frog suit or something to keep the acid off your skin. So there you go. You could actually live on Venus. So I've covered that. I got a whole video about living on Venus. But anyway, I just wanted to point that out. So this is the orbit of our target, Dimorphos and Didymos. And this is about where it is now. And it's 0.071 astronomical units apparently away at this point. So that is, an astronomical unit's 93 million miles, my friends, this Earth and the sun. So it's still millions of miles out there. It looks close to Earth. It's, when you consider the whole solar system, it's not as close as one would think. But anyway, it goes way out. So that's interesting. Maybe there's something there, my friends. Let me stop share. Hello. So there you go. So we have found evidence brought back by Hayabusa 2 from Ryugu that sound like a spaghetti mix. Spaghetti sauce. Maybe it is a spaghetti sauce, except it's got bugs crawling in it. Maybe. I wouldn't hold out a big hope in that area, but there's a possibility the panspermia might be shared on some asteroids or comets. But as I mentioned to y'all, I've got a personal connection with Gerard Kilnell. I have met him, and I met him 42 years ago. Yeah, kid you not. 42 years ago, he was active in space, and so was I. Here I am. Oops. That is me. 42 years ago as a soldier. I was stationed at Fort Greely, Alaska. We were at the University of Fairbanks in Alaska. Now, Fort Greely is 100 miles away. The nearest red light's in Fairbanks. So we were 100 miles from the nearest red light where I was stationed at. If you drew a circle around 100 miles in diameter, you'd have had 2,000 people inside the whole circle where I was at. It was remote. It was like living in a Mars base. That was my camera bag back in the day. That's me. Here is Gerard Kilnell. Yeah, I was a lot skinnier, no beard. I was like in short hair. I was in the Army, remember? That's Gerard Kilnell. And I was presenting him a plaque. That's just a pin set. You see that, guys? You see that pin set I was presenting him? That was one of these right here. I've got one. Still after 42 years. North Star L5 Society. It says on there, lunar and asteroid resources. That's what it says if you can read it. Lunar and asteroid resources. You see this? This is basalt. And the face was cut off to mount this plaque on. Basalt is a volcanic rock. So that made kind of a stony, chondritic rock, right? So this one's been collecting dust. So it's been migrating toward being a little bit carbonaceous. You see some of the dust in it. But in any event, this is identical to what we gave to Gerard Kilnell 42 years ago. And that very night after, it was 60 below when Ed Kiker and I've had it on, I think on my Green Grapes channel. Ed Kiker and I drove in his Chevrolet Suburban, whatever the thing was, to Fairbanks, and gas was freezing and trying to get to the carburetor. That was interesting. It was cutting out because gas was trying to freeze. And when we got back that night, I saw the best aurora borealis I ever saw. It looked like somebody poured water paints in the sky, and God has his hands up there doing this. You even got it. That's what I love. Like some big fingers in the sky, just playing with the water paints. It was amazing. Best aurora borealis I ever saw the night after I met Gerard Kelnell. And it was after we got back, and it was pretty late. But anyway, there it is again, my friends. It was wintertime. Alaska's Alaska. Yeah, I would have had a parka to put over that coat when I was outside. I assume he did too. There you are, Gerard Kelnell. I will talk about his space colonies in a future video because that's one of my favorite topics. That will be an upcoming topic. I got a backlog of upcoming topics to talk. I still need to talk about the politics of space vis-a-vis the creation of both commercial space and things like the SLS program, roles I played in that. We're going to talk to you about quite a few things coming up, guys. Quite a few things. We got, like I said, good backlog of topics. So if you're not subscribed to this channel, please subscribe, bang the update notification bell, and click all. So I highly encourage you to do that, my friends. So with that, I'm going to say thank y'all for watching, and Greg out.